Okay, so I'm going to just talk about the syllabus and the structure of the class, and maybe we'll have a few minutes at the end to talk about like what this class is and what's you can, like, in a way this class is just sort of a continuation of statics. You know, we with statics we're able to analyze all the external loads. We started talking about internal loads, and then we're going to go a step farther than internal loads to calculating the stresses at a point, and we'll be able to, stresses are really the last step to figuring out where something's going to break, if it's going to break, you know, which is a pretty, you know, powerful tool to have when you're trying to design a structure, a machine, or whatever. Okay, so I'm going to start with the syllabus. First I want to say the same thing I said in dynamics. The main, yeah, right. So the main thing here is, so how to approach this class. And I really think there's nothing conceptually too hard about this class. There's some three-dimensional thinking that can be a little tricky sometimes. I'll try to give visual aids that'll help with that. But really, I think the key to doing well in this class is just spacing out your work on this, you know, not letting things bunch up so that you have to have a huge rush before the exam to figure stuff out. And so for a 3-credit class, the general nationwide expectation is that you're going to put 2 to 3 hours into the class outside of class time for each hour in class. So let's call that 7 hours. So that rounds up to total time commitment for this class of 10 hours. 7 hours outside of class, which is basically an hour a day outside of class. And the more you can space it out, not everybody's going to be able to do it every day, but if you can space it out into every other day, 2 hours every other day or something, it's just going to go much better than if you try to do it all in one all-day session on Sunday, or even worse. And I mean, I was in college too, like 50 years ago. And I remember, you know, sometimes your horse wouldn't get to school or whatever, you know. But, you know, you have good intentions, but you have other projects due or whatever. I've put this off, and then all of a sudden there's a test and you end up pulling an all-nighter or whatever. The less you can do that and the more you can just be steady and do it all the time, the better you're going to do in this class. One of the reasons you're going to do better in this class if you space it out well is that everything, the whole way that I grade this class is intended to reward people for spacing the work out. And the reason that I try to reward that is because if you're doing it a little bit every day for 16 weeks, 6 months after the class is over, you're going to remember 1,000,000 times more than if you did it in 5 study sessions, or you know what I mean. So that's where I'm at. Try to find something on your schedule where you can do it an hour a day or 2 hours every other day, something like that, not where you're going to have these Herculean efforts to get ready for a test, you know. Most of your study time should just be solidifying concepts, you know, or solidifying habits, doing problems that you know how to do them. You're just trying to get the tools smoother, you know. So right after I give the assignments in the next day or two, that's the time to try to sort things out. You should try to understand all the topics within a couple days of me giving the assignment. The rest of the time, the majority of your time working on the problems, should just be solidifying it. You're just trying to get those to be tools, you know, where like eventually your ideal goal is like a problem comes up, engineering problem comes up, and you're like, it would be useful here to be able to calculate the stress, this thing's round, I have a tool for that. That's what we're trying to get to, you know. And so on tests, I'm not trying to make you think, do a ton of thinking on tests. I'm trying to get you to show that you're developing those tools, you know. So as much as possible, break your studying into 1 hour a day or 2 hours every other day. All right, so now let's go through the syllabus. Virtually identical to the syllabus we just went through this morning. That's the good news, because everybody likes hearing the same stuff over and over. All right, so I think I pretty much know everybody here, so everybody's familiar with D2L. If that's not true, you know, if you have trouble getting hooked up to D2L, just go over to the IT desk and they'll get you hooked up in a second. But anyways, to get to D2L, go to the main Normandale page. There's a little tab at the top. Click on that. Use your star ID to get in, and then this is the main D2L page. It'll list all your classes over on the right. And so click on DForm. And the first thing you see is the announcements. I will try to be good about always posting every day's assignments in the announcements, telling you when I'm going to expect you to turn it in. Whenever I change something with the problems or change something with the solutions, I'll try to be diligent about making a note there so you know to reprint things or whatever. For now, what we want is in materials content. And there are a few things that are already entered in here. The first one is course information. There's a syllabus, a vector review, and some programs that'll be useful for a TI-89 calculator. If you have a different calculator, you need a graphing calculator of some kind, but you can do all these same things in any kind of graphing calculator. So if you can't figure out how to do yours, come talk to me and we can probably figure it out.
Are these different than the ones from Dynamics?
Some are overlap and then some are slightly different. That first one, the compliance matrix, that's not something in Dynamics, so that's, but some of them like cross product and whatever that tells you how to do that, those are useful for any class, so those are listed in both. And then the vector review, I'll talk about that in a second. And then all the problems that you're going to do over the semester are in the assignment problems. The same as I did in statics and the same as I'm doing in dynamics. Each day I'm just going to give you, basically give you the next chunk of problems, whatever we're ready to work on after that lecture. And I'm going to give you the assignment in the announcements, and I'll say when that set of problems should be stapled together with the other ones and turned in. Yep.
Just because I'm curious, is the first vector assignment exactly the same?
Yeah. So the people who are in dynamics, it's not exactly the same as statics because I've changed some things, okay. But it is. It's the same as the one in dynamics. So if you are in dynamics, just write a note on your problem set that says you already have this. Yeah, you don't have to write that up twice. Yeah.
I went through the assignments as well, and a lot of the pictures look similar.
Oh, yeah.
The verbiage looked different.
Yeah, that's true. They're a lot of the same figures because making figures is a pain in the butt.
Okay.
So
So my next question is a lot of this curriculum that we're going to embark on now, is that from the piggyback from dynamics?
yeah,
So
from
therefore-
statics.
Oh, I'm saying, right. So
Yeah,
from
right.
statics. So
Yep.
we can, that's a good tool then to refer back to then?
Oh yeah, for sure. And we'll take some time to refresh some of the stuff from statics, the stuff that you're going to need to use. But like, for example, calculating structures and things, calculating external loads and structures, that's going to be like a first step in problems. Well, you know, like at the end of statics, towards the end of statics, we would calculate the external loads in a structure. Then we'd take a piece, calculate the internal loads in that piece. Now we're going to take the next step and use those internal loads to calculate the stresses,
Okay.
which basically will tell you yes or no, it's going to break here, you know.
Gotcha.
So yeah, this really does piggyback off of statics quite a bit. No, I would say, okay, so it's a prerequisite, and knowing statics would make a lot of stuff easier, but I think if you're willing to spend a little extra time, and I think you can take this class. I mean, I've had many people take this class, do fine without statics. You're not the only one doing it, but if it's a concern that it's going to make it a little bit harder, then we should talk about it, you know, before you decide what to do. And then there's solutions to, it's just basically the same as statics and dynamics. There's solutions to maybe 3/4 of the problem, something like that. Yes?
So the whole topic is stress, calculating stress? Or
Basically, stress and strain are the entire class, yeah.
oh, okay. But different, like material structures, right?
So basically, we'll be calculating stress and strain, and the thing that changes throughout the class is the geometry of the objects that we're analyzing.
Oh, okay.
And then there's a couple of other things too, but that's the heart of the class for sure. Oh, and then I'm doing all these lectures, you know, the same as in statics and dynamics. I'm recording videos as I go, so the videos will all be posted on YouTube. PDFs of each lecture will be posted. And there's a section here on D2L called Old Lecture Notes that's, I guess, the lecture notes from last spring. So, you know, it changes a little each year. I, you know, make changes to things, but for the most part, these are the same lectures that you're going to hear this time. So, yep.
I was going to ask the last class, do you think it's like doable to print out your old lecture notes and then like have them in class when you write your new notes? Are they close enough?
Probably not always. Often they will be, but then some days it won't be. I don't know. That's a good question.
Because you do post the notes that you posted and then I can print them out the day after, right?
Right.
What I
Yep.
did last- okay.
Yep. That would be nice to be able to just print out the old ones and then just take notes in the margins, but there's always some lectures that, you know, I reformat or whatever quite a bit.
Maybe different story.
Yeah.
Monthly.
Yeah, well, sometimes I just change the, like, you know, like say things just didn't go well. I'm like, wow, people did not get it the way I did it last year, and so then I'll change things, you know. All right, so the story now is the syllabus, which is in course information. That gives my contact information. My email works better than the phone, but I will get phone messages too. I told you last semester I don't even have a phone in my office. Like I just have to see on my email that I got a phone call and then call from a different phone. So, but emails are definitely faster. My office is 2302. Oh, I said in dynamics, that's also the last 4 numbers of my cell phone. Isn't that crazy? Like there was one day I'd been at Normandale for like 5 years, and somebody asked me what my office was, and I was like 2302, and then I'm like all confused. I'm like, wait, that's not my office, that's my cell phone. And then I couldn't remember what my office was, and then when I looked, I'm like, I'll be damned, that's the same number. And the area code 612, so 1 in 1,000 chance of guessing my cell phone number. But if you call it, I'm going to be sort of pissed.
It's better than earlier. You said you're supposed to pick up.
Oh yeah, right. In this class, I will pick up, but I'll be angry about it. In the other class, I'll stay in a good mood, but just ignore the call.
Wait, I have a question.
Yeah.
It's not related. It's kind of funny. Like, adding you on social media, would that be okay or not really?
Doing what?
Like, add you on social media.
Oh, I usually, I've never really come up with a clear policy. I guess the way I usually do it is like I have a lot of former students who are like Facebook friends and stuff, but I usually wait until you're basically done with my classes. Okay. It's not a big deal either way, but after that, for sure. Yeah. Before that, it feels a little weird because I post so much inappropriate stuff.
Angela through Jay?
Yeah.
A lot of us are friends with her on Facebook.
Uh-huh.
I like double check every time I post something. I'm like,
Yeah, exactly. Right. No, I know. It's sort of weird. I sort of, anyways. My office hours are Mondays and Wednesdays, 11 to 12, Tuesdays and Thursdays from 10 to 11. And I don't currently have like a lab available where we can do the study hall type office hours. I know, those are great. So what I'm going to do, I'll talk to the tutoring center. I think we're allowed to just do office hours in the tutoring center, and then we can do it the same way. The problem is just the times I'm at school and have my classes is all during the day, and none of the labs are free during that time. It's just because I don't have that night class. But I'll look into that because everybody likes those, I think, where there's just people around to work with, and I'm just sitting around in case things come up. The prerequisites are statics. Like I said, there are two prerequisites and one co-requisite listed. Statics is the most important of those three. Statics will help quite a bit in this class, but like I said, you can do it without statics. I majored in math in college, and then I did a master's in biomedical engineering, and then I did a PhD in engineering mechanics. And so basically, from the time I finished college until I finished my 2 tours of duty in graduate school, I never took a class that I had the prerequisites for. So yeah, you can always get by. The teachers will always wring their hands because they like to think that these classes are only possible because you remember so much of what they taught you before. You don't remember anything. And so they have to do a review anyways, And you just learn from the review, and then it goes fine. It's probably not the best way to learn material, but it'll go fine.
Maybe spend more extra time.
Yeah, right. It'll take a little extra time sometimes, but you can get through if you whatever. I had this one class where I went and talked to the professor. I'm like, yeah, is it okay for me to take this class? I don't have the prerequisites. And he's like, well, which prerequisite don't you have? And I'm like, I don't have any of them, It's 12 of them. I don't have any. Take it or leave it. And he's just like, oh, no, and I was going to, it just happened over and over again. I'm all nervous after talking to him. I'm like, I better drop this class. This is where the shit's going to hit the fan finally, And then it just kept going fine. And I got an A in that class, no problem. And so finally I'm just I'm just not telling them anymore. They'll be happier, I'll be happier, So that's my take on prerequisites.
Do you want us to bother to get that form signed or not? Because, I was able to register for
Oh, if you could register, then no problem, yeah.
I registered.
Yeah, don't worry about it.
It was okay, I registered, but I don't know why. They told me prerequisites, they show prerequisites. registered fine, like it's
Mhm.
went through, but they say prerequisite those classes you mentioned here.
All three of them.
Yes.
You know,
I
so
don't know why.
last semester was the first time that they ever enforced prerequisites. And there were some issues, you know. And so I think it's possible that they just, while they're ironing the bugs out, they just removed the gates, you know. So the prerequisites are still listed, but it's possible that, I don't know if this is true, but I think they might have just made it so you register and you're just sort of on your own as far as whether you're ready or not. Yep.
Just curious, how long did it take you to finish your PhD?
Well, it took, those were two different departments. So I did, it took me like a little over 2 years to do a master's after college. And then I worked for 3 years. And then I switched departments completely. And then it took, I think, about 5.5 years to do a PhD. So I was in grad school a long time.
I have a question.
Yeah.
Have you worked like in companies?
No, but the job that I did, I was like, I was in a hospital. I was the engineer at a biomechanics lab in a hospital. So I did some sort of like patients would come in and we'd do testing and stuff, and then I did like research too, and so I would go to conferences and that kind of stuff. So that's what I did. It was never, I was always, you know, actually this is, most of what I'm saying isn't very interesting, but this is interesting. My only job working as an engineer, I was the only engineer there, you know.
Really?
And it's terrifying at first. And you know what I mean? Because you're like, and it's like patience and stuff, you know, like, and like, you have to get this stuff right. And I think one of the things, I mean, that really made me do was, and as you know from like the solutions I write out, I mean, I make a lot of mistakes. I mean, like most people do, you know, like so, and so most of my thought went into figuring out how I could make sure that, you know, how I could come up with a calculation and then figure out creative ways to test it and do this and stuff, you know. How do you make, without anybody else looking at it, how can you be sure that what you're saying is right, you know? And I've spent a ton of time with that kind of stuff.
Yeah, but you got probably, it's a good job, right? You get maybe paid more, I don't know.
Well, yeah, I mean, it was a good job. I don't know. It probably wasn't any more than, you know, I probably didn't make any more money than at any company or whatever, but I really liked it. Yeah.
More responsibility.
Uh-huh, right. But yeah, it was just, that's a very, it's a nerve-wracking thing to be like, yeah, you're the last person making sure this stuff is working and accurate and, you know. And then it says that differential equations is a co-requisite. That is not going to come up at all. All of these things are we just mirror what they require at the university. So you can think of these as just sort of, mostly these are just guidelines, like you need to have these classes. If you were taking it at the U, you'd have to have them by now, so you better figure out how to fit these into your schedule soon, you know. But there's not going to be much calculus. There's not going to be any differential equations, really. Statics will help, but we can work around that.
I just have a question. Since you're an engineer, do you have to take any like programming class? Like I took C++.
Well, everybody's experiences are so different. I think every engineering department, you need to take something like C or C++. I happen to, like, the stuff I went into was all programming, you know, like every research project I did was, you know, multi-thousand line programs was how I did the calculations. But that's very different than a lot of people's experience. There's just so many different experiences people have in engineering.
Oh, okay. Because I need to learn more about, like, I took C++, but I heard about, like, the MATLAB and those kind of useful tools.
Yeah.
And those other Maple.
Yeah, MATLAB is a great programming environment. I love MATLAB. You can, you know, it's expensive, but if you're working at a company or a place that has MATLAB, you can do all your programming in it. It has a great like graphical interface support. I mean, I actually, for a long time, I was working on this project just doing graphical interface on MATLAB for hospital software that like the doctors and the whatever were going to use, you know. And I think I mean, you can do such professional, cool-looking stuff in MATLAB, and it's basically like programming in C, you know.
Will you be able to teach programming class or?
No, it's like a union thing or whatever. Like it's related to credentialing, you know. So you know, all the engineering and physics people have done a lot of math, but a lot of the math is in the physics or engineering department, and so it doesn't count for your credentialing. You know what I mean? And so same thing with computer science. You know, like we've done a ton of programming, but it wasn't in a computer science department, and so yeah, but yes.
You know, just because I'm curious now, how did somebody with a biomedical engineering degree get into teaching statics and dynamics?
Yeah, well, biomedical engineering is super broad. You know, I mean, it covers all these different areas. Like there are biomedical engineers who are just totally electrical engineering, and other ones who are just totally chemical engineering. And the stuff I was doing was biomechanics, and I was doing orthopedic biomechanics, which is basically just like forces and couples that are acting on the bones and the muscles.
Oh, okay.
You know, so I was doing like statics and dynamics calculations.
Okay.
Yeah, but just instead of a thing made out of steel, it was made out of biological tissue. So it actually fits pretty well. But, you know, like other people who do biomedical engineering.
Didn't Derek do it?
Oh, yeah, right. And right, he did nothing, not even remotely related to the stuff that I did. You know, he was working on magnetic resonance and I think some optical stuff. I don't remember exactly, but totally unrelated. But they're just both called biomedical engineering because
So you've known Derek before coming here?
No, I didn't.
Oh, okay.
But, you know, we were both doing biomedical applications, so that's why they call it that. It's sort of a funny thing to lump together into one department in a way, you know. Yep.
Kind of getting back to the syllabus.
Yeah.
You can't count or something. You got like two
No.
twos there.
I have what?
You got 2 number 2s under course objectives.
Dang it.
Sorry.
Can't win them all.
No. Okay, let's skip that then.
Another question, how did it take so long for somebody to notice?
Yeah. Well, I wonder if, I don't think I changed that this semester. Okay. Now it's fixed. So for required materials, you need a good calculator, a graphing calculator where you can do vector and matrix calculations. I have a TI-89, that's why I always talk about that one, but any of the TI calculators will work fine. If you're in the market for one, I would recommend making sure that you get one that does eigenvalue and eigenvector calculations. In this class, we're going to do those calculations, and it'll save you some time. TI-89 does that. The Inspire does that. The 84, 86, and 83 don't do that. It's not a big problem if you don't have that. The books, Gear and Goodnow is the textbook that they use for this class at the U, and so that's why I list it. It's formerly, for a while before Goodnow, Gear and Goodnow, it was just Gear, and then before that it was Gear and Timoshenko. But those are all the same textbook, just different versions. Really, the only thing that tends to change is the numbering of the problems and stuff.
Is it required? Or
What?
required the book?
No, it's not required. You won't use it in this class at all. It's just for future reference. I think it's probably a good idea to get a textbook. But the same as with statics, my approach in this class is going to be pretty different from any textbook. So this class is pretty much just, I wouldn't I wouldn't depend on a textbook at all for this class. I think it's just going to make it more confusing. I was saying earlier, in dynamics, the way I do it is a lot closer to the way the book talks about it, but in this class, it's going to look pretty different. And then the second one I recommend is Sham's Outlines. I always say you might as well get Sham's Outline for every class you take, because the class costs, $300, and a Sham's Outline costs $15 or $20, and it gives concise little descriptions of the topics, and then it gives tons of problems. Most of them have answers given. Some of them have full solutions given. So it's just a really nice thing for going back and refreshing your memory. Like when you're trying to take that first, like the fundamentals of engineering exam that some people take like your junior year, it'd be a great resource for something like that. The grading scale is the same as it was in statics, same as it is in dynamics. Sort of high looking, 94, 84, 74, 64. But I think that sort of reflects the way that I teach the class. I mean, I think I try to teach it in a way that nothing comes at you that's too much of a surprise on exams or whatever. And I think if you consistently spend the time working on those assignment problems, you should be able to do everything on the test. That's sort of the way I think about it. And the grade breakdown is the same as dynamics, a little different than it was in statics. Just the quizzes are devalued a little bit. So it's 70% exams, 20% assignments, 10% quizzes. The exams, there are 5 of them. Each one is worth the same amount, so each exam is worth 14% of your grade. No, that's including the final. So the final really isn't any different than the other ones. They're all cumulative, though. So you have to sort of stay up with stuff as we go. There's exceptions to everything, but for the most part, there are no makeup exams. So if you miss an exam, you get a 0 at that time. But the 5th exam that you're going to take during the finals period, if your 5th exam has a higher score than any of the first 4, then it replaces the lowest score of the first 4. So like, say that you did well on exams 1, 2, and 4, and then you get a 90 on exam 5, okay? But exam 3 you didn't do as well on. You either missed it and got a 0, or you got, 30% on it or something. So the way that works is the score for the final, the 90, counts as a 90 for exam 5, and it also replaces the 0 or the 30 for exam 4. So you end up, that low score or the 0 because you missed the test get overwritten by the score of exam 5. Okay? So that's sort of my makeup policy. I list all the dates of the exams here. I mean, if you're going to miss an exam, come talk to me. Maybe we can work around that or whatever. But for the most part, I mean, if you can't make it to these exam times, it just might not be the semester that this class is going to work out. And I think all of the finals are already, the final times are already available. So I didn't write it here, but as soon as you need to know that, let me know and we can find out when the final is. Any questions about the tests? So the tests are 70% of your grade, the big majority of your grade. The next biggest part of your grade is assignments. And just like in statics and dynamics, I'm going to collect those every 2 weeks. I'm going to do that on Fridays so that when you have exams, you'll turn it in with the exam if anytime they match up. I'm going to make the due dates clear. I said in dynamics, just because of the number of classes I'm teaching this semester, I can't be as loose with due dates as I was with statics. But if you come talk to me beforehand, we're just going to have to decide on a time that assignments are going to come in. This semester, I just need to know when I'm going to have all the assignments, So last semester, when it was basically like I get everything in by the end of the semester, I just can't do it that loosely this semester. And I expect all of these assignments to be done to look nice, the figures to be done carefully, and I expect the problems to be in the order that I assign them. Okay, so I don't want to have to look all over the place for number 4 because you didn't know how to if you don't know how to do it and you can do the other ones, you just have to write it all up again. You know what I mean? I'm not trying to be too strict about this, but I think that's a reasonable expectation.
Or we can put space between problems if you don't know, right number 4 or something.
Yeah, right. You could do that, I guess. Yeah. I think working together on assignments is a great idea, and it's a great skill to get, an important skill to get. And so I'd like you to do that as much as possible. I just want to make sure that the work you turn in reflects your own understanding of the material. And so to me, what that means is you can work together with other students to gain an understanding of the problem, jot some notes down, scribble some things out, so you'll have a paper with the bare bones of how to do the problem. But when you write the paper that you're turning into me, you need to be able to do that without consulting the notes. That your understanding of the problem needs to be at that level. That's the way I think of it. So working with someone else, you got this understanding of how to do it, but now you should be able to go over here and do the problem yourself. If you don't, then you don't then that's not your understanding that you're showing me when you turn it in. So that's the way I think about it. If you have any questions about that, I can talk to you about it. But I want you to work together as much as possible. I just don't want you to turn in work that you don't understand. And really, almost that exact same thing goes for using the solutions to the problems, now that I think about it. You're going to be turning in problems. A lot of the problems you're going to turn in, I've provided solutions to you. You can use those solutions to figure out how to do the problem, but the stuff you turn in is supposed to represent an understanding of the material, not just copying down the solution. You know what I mean? Okay, and then the last part of the grade is the quizzes. Those add up to 10% of your grade. In statics it was 20, so now it's only 10. Those are the ones that usually the scores are the percentages are the lowest on the quizzes. It can be a little hard to get ready for. But every other Wednesday, we're going to end class with a 10 or 20-minute quiz, and there are 2 kinds of problems that will be on these quizzes, or 2 kinds of questions. The first is just questions about stuff I said in class, And so to get ready for those kind of questions, you just need to be reading your notes, going back and skimming your notes later, just keeping your mind refreshed on what I said in class, What's the subscript notation for Newton's third law? That's the kind of problem, And there'll be a place in the notes where it says that. And if you remember your notes well enough to remember that part, then you're going to do better on the quiz. If you if you haven't looked back at your notes at all, you're going to do worse on the quiz. And then occasionally I'll also put problems or parts of problems that I've assigned on the quizzes, and you just need to recreate what you did in the assignment. So just trying to keep you refreshing your memory of the problems that you've done. The quizzes are cumulative, so it's not, the quiz isn't just from the time of the last quiz to the new one. You should be refreshing your memory on everything that we've done up to that point. Yep.
Just curious, do exam and quiz dates fall in line with the same date in dynamics?
No, they're switched.
Okay.
So all the exams in dynamics are on Wednesdays, and all the exams in this are on Fridays.
Okay.
And opposite with the quizzes.
Homework due on the same days?
Yeah, the homework is due on the same days as the exams.
Okay.
So nothing matches up from the two classes. They're all flipped. And then don't cheat. Anybody have any other questions about the class?
So, the exam have to like, I don't know. I still I understand sometimes the materials, but the exam I don't do that well.
I think, so, can I add in something?
Yes.
It's exactly what he said earlier in the other class for, what is it, the T-form? I'm going to get these confused all the time now.
Yeah.
The other class, he was saying, with the homework, the day he assigns the homework, you should be able to do the homework, and then the rest of the time until it's due, you're just practicing.
So every day do like 1 or 2 problems.
Yeah, and if you can't do it by the time he, like the day he assigns it, then you should have talked to him.
Right.
Yeah.
So yeah, I do think like most of your time doing problems should be just reinforcing habits. The understandings that you need to do, like understanding the concepts, that should be pretty early on in the process. And I don't know, it's tricky to give like a blanket answer to that, because different people have different levels of just like, some people are really comfortable in testing environments, some people get more nervous, some people like need more time, and I think the answers are different for everybody. I try really hard to make these tests in a way that if you have understood how to do the problems to the point that you could explain to someone why you did that problem that way, then you should feel comfortable and feel like you have enough time on the exams. That's what I try to do, and every semester I keep trying to tweak things to make it more that way. The thing I get out of making it that way is like, I want as much as possible to make you feel like every hour you spend studying shows up in your score, because then otherwise people are like, there's no point in studying, it doesn't, you know what I mean? So I try really hard to figure out how to make those problems really pay off on the tests. One thing I'm going to do this semester that I haven't ever tried before, it sounds sort of wacky to me even sometimes, but I'm going to try it. I always say you should do all these problems at least twice. I always say that, but this semester I'm actually going to have you do submit problems 2 times during the semester, so that I actually see you do it the 2 times, so I don't know.
Or maybe you can assign.
Let's just keep talking about it as the semester goes on. Yeah. Let's just keep talking about it as the exam gets closer or whatever, and maybe I can give some suggestions.
Yeah.
Okay.
Because I really I understand like sometimes the concept, but sometimes when I go testing,
Yeah.
it's just like I get a little bit nervous.
Right.
I get like anxious.
Yeah.
So I mess up sometimes.
Yeah.
With the exam. Yeah.
Yes.
When is spring break?
Uh,
The reason I'm asking is I'm taking considering taking the lead certification test around that
Oh, okay.
time.
It is, I think it's right before that quiz 4 there.
March 6th through the 11th?
That sounds about right, yeah.
Thank you.
And if anybody, actually in the last class, somebody asked me about an exam that they're taking, like a certification. If you have something big like that going on, I'd be happy to, move the schedule around. So if there's an exam that falls like on the day or the day before you're taking some important like work, have some important work thing, we can work around that. Okay?
Okay, thank you, guys.
Any other questions?
Oh, yeah.
Yes.
Is it possible to have like two engineering exam at the same day? Like
Not in my two classes, but if you're taking, are you taking circuits one this semester?
yeah.
Yeah, good luck to you. No. It's just so hard. I mean, it's just so much time, I think, It's just very, very time consuming. But you're going to learn a lot of circuits. I promise you that much. So I don't know. I don't, maybe I should in the future, but I don't coordinate with Derek on, but
Do you coordinate it with your statics class? How does Lindsay?
yeah, those are all on different days. Well, statics is a Tuesday, Thursday class, so those can't. Yeah. All right, so Wednesday we'll talk about deform for the first time. Actual, what happens when things deform.
I really want to have a study hour.
Okay. I'll go over.